Welcome to another edition of RCE. Again, this is Brock Palen. You can find us online at rce-cast.com. You can find all the old shows, subscribe by RSS, and there's also a direct link to iTunes there. Also, again, I have Jeff Squyres from Cisco Systems and OpenMPI. Jeff, thanks again for your time helping out with this.
Hey, Brock, this is always cool stuff. I love to come and talk to the various people here and find out new and interesting things that I didn't know before. So it's always an educational experience for me. And I even get to write about this on my blog sometimes there. Because did you like how I snuck that in there? The marketing overlords like me to mention my blog on here. So I have to find a way to mention it every time.
No problem. This package that we're going to talk about today, I found out about from a friend of mine who's using it not on the system I'm administrator for, but then after we set up the interview, but before this recording, I had a user request it. So I've recently gone through the building of this package, which is a gigantic, very versatile package. But I'll let our guests describe that. So our two guests today are Mike Heroux and Jim Willenbring, and they are both at Sandia National Lab. But guys, why don't you go ahead and take a moment to introduce yourself?
Sure. I'm Mike Heroux. I've worked for Sandia since May of 1998. Prior to that, I was at Cray Research, so I've been in HPC for a long time. I and also Jim, you'll find out, actually telecommute for Sandia. We both live in rural central Minnesota, and I have worked at Sandia and also teach part-time. I'm a scientist in residence at St. John's University here in central Minnesota.
I'm Jim Willenbring. I've worked on the project for 9 years. I'm part of most of what happens in Trilinos that isn't specific to a Trilinos package. For example, the build system, testing infrastructure, general planning for the project. My official role is the Framework and Tools Capability Area Leader.
So the package we're talking about is Trilinos. So could one of you guys explain to us exactly what Trilinos is?
Yeah, this is Mike. I'll get started. So Trilinos is several things, and depending on who you are, you care more about one aspect of it or another. First and foremost, it's actually a fairly large collection of independently developed packages. Each package is developed by a small team of people, typically 2 to 5, maybe 7 at most, and each package is focused on one particular set of capabilities that are needed by people who are doing computational science and engineering or other technical computing areas. For example, solvers is our heritage, but we do much more now. So it's this collection of libraries. It's also the framework that Jim mentioned that he manages and keeps track of that allows all of these packages to coexist, not step over each other, and build together, and a collection of tools that make the development and software engineering processes easier. And then third, and maybe as important as the other two is, or maybe more so, is it's a community. It's a community of people with like interests and goals that meets on a regular basis, talks with each other, rubs elbows and shares and argues and cajoles and everything together as we try to provide this huge body of software to the scientific and engineering and technical computing communities.
Okay, so I've been for a number of months now calling it Trilinos, but I guess that's not actually the correct way it's pronounced. How is the package actually pronounced?
We tend to say Trilinos, but certainly there are others who pronounce it as you do, and it's okay to be bilingual.
Okay, so now I've got the free pass because it's gonna take me a while to get it beat into my thick skull the right way to say it. So where does that name come from? What is that derived from?
So I arrived at Sandia in '98, and there's this heritage of naming projects by Southwest names, Chaco, Jemez, Sierra, things like that, and that namespace was used up, and I started thinking, well, what's another language that has interesting terminology? And I thought, well, Greek is pretty good. And so I started looking for Greek words, and here was this picture of a three-stranded string of pearls, and I thought, that's beautiful. I had this notion that we wanted to do individual packages and have that put together in some kind of meta framework. And so that image has always been part of the project. And so Trilinos comes from this notion of a string of pearls. The try in Trilinos was actually our grand vision of 3 packages. And so we thought we were going to do 3, and now we're up to, I think, roughly 57 or so. But that's where the name comes from. And you'll see that there's this Greek naming theme, not completely, but throughout the project. And so there are a bunch of packages in the project, many of them which are less pronounceable than Trilinos or Trilinos, if you will.
That has got to be the best thought out rationale from a name that I have ever heard. That is fantastic. So give us a little more of the history, right? So you started this project up and you had this grand vision of 3 packages. What were the original 3 packages? I mean, what was the scope back then,
right.
and how has it evolved?
Right. Data classes, which eventually evolved into what we call the ePetra package. Linear solvers, preconditioned iterative methods, which became the Aztec OO and ISPAC. It split into those packages, and then nonlinear solvers, which evolved into being a package we call NOx. Those are the 3 basic capabilities we thought of. The whole project grew out of several competing needs. One is we had lots of algorithms developers who were given funding to develop new capabilities. That on one hand. On the other hand, we had some very what seemed to be onerous software quality engineering requirements coming down to us from the Department of Energy offices. Them telling us that there are certain processes and practices and assurances you have to make about the quality of your software. And so on the one hand, we had small teams. On the other hand, we had big demands. And so the idea was, how about if we created kind of a federation of algorithm development teams, and then together we can come up with policies and tools that address this big problem that no small team alone can handle. And so really that was the kind of the pot that put this all together.
So I noticed when I was building Trilinos and I was trying to build every sub-package that I could, the source code was almost 100 megabytes. And when built with all the object files around, it took about 14 gig. This is a huge package. So how many people are involved with this project, and how do you delegate who's responsible for different packages?
That's a good question. So each package team has a package leader. That person is responsible. Remember, I said there are about 57 packages. So each package team has a package leader. In addition, we have 8 what we call capability area leaders who are responsible for being proactive in a particular area. For example, linear solvers would be one, or meshing geometry. And then on the top is me, Mike Heroux, as kind of the nominal overall project leader.
So what would you say one of the primary uses of Trilinos is? Do you guys only work on the individual packages, or are you actually users of it in a higher level manner and you contribute back?
Yeah, we are all users of each other's capabilities. We have a set of strategic goals. One of them is that if it makes mathematical sense for one package to use another, then we create that ability for one package to use the other. So yes, we are our own users in addition to being developers. We have literally thousands of users throughout the world, in addition to being the primary deliverer of capabilities in libraries for Sandia, and now a growing presence at the other national laboratories in the U.S.
And many of the developers...
Go ahead. Sorry, I was going to ask the next question, but if you've got more, go right ahead.
Oh, I was just going to add, many Trilinos developers are also